Now I know that this is a review from the past. There we go. And what we did is we started with an activity, and I gave some cards given to a group, and I asked them to, and I put some cards on the board, and I asked groups to put them or to figure out where their card might fit. So when I put my cards in the board, I had two columns, and I put numbers like 1.2 and 2x and 1/4 or a 3y squared. And I had -3 went in column A, and in column B was 4xy or a -x, something like that. So we tried to figure out why did we put cards in each one of these, and we figured out pretty quickly that column A were just simple numbers and B were terms or were different groups of terms that had variables in them or had letters. Okay, an x, a y squared, an x, and an xy. So then after we did this, I gave groups a whole bunch of cards, and I said, open that up and group your cards however you want to group. Well, a lot of people started with sorting into that A and that B category of just plain numbers and some numbers that had some variables along with it. So they started there. And then I walked around and said, okay, how could we possibly break them down even more? Well, some people broke them down by negatives and positives. Some people broke them down by they had numbers with variables, but they had decimals in the front. And people broke them down a whole lot of different ways. It was multiple different ways that people broke them down. Then I came in and I said, okay, I'm going to give you I want you to help me group them. So I made some groups on the board. Okay, and I said, okay, give me some of the terms on your cards, and I started grouping them, and I wanted people to see, okay, why am I grouping them the way that I'm grouping them? So here's what I did on the board. So I said, okay, a 1.1 would go here. A 4x squared went here. A -3 went here. People were just calling out cards at this point. I had a 2x. I had a 5y squared. I would have a -0.3y. I would have 5x, -2x. I had just a -x in one of the cards. We would have a -6y squared here. We could have a 1/2 y. There was a 0.3x squared. There was a 1/3. There was a bunch of different ways. And we said, okay, can you start figuring out why I was putting these cards or these cards in these different columns? And we picked out pretty quick that it was because of the variable. Okay, so this is because of all the x's. If we had to name what was the rule to put in column 3, we would say it was the y's. For column 4, we would say, okay, this was the x squareds. This column was the y squareds. And then this one we just called plain numbers. Okay, there's a special name for this that we're going to get to in a second, but we said, okay, these were just the plain numbers, what made column number 1. Okay, and then we looked back at our cards that we put in column A and column B and said there's one card that wouldn't fit in any of these categories, and they said, oh, it was a 2xy, and it didn't fit with the x's and it didn't quite fit with the y's, so really it made its own category. So we said, okay, what's the most important part when we were grouping up these cards? It has to do with the variable. So the key here is always look at the variable, okay? Later on we said, okay, these are called special names, and we're going to get to these terms in a second. These are in your notes that you took. and these just plain numbers are called constants. Because a 1.1 is a 1.1 is a 1, like that doesn't change. There's nothing that can change the fact that it's a 1.1. These are called, they all have in common, they all have a variable. So these are called variable terms. Why? Because they all have a variable, and their value can vary because whatever x is going to change what the value of 2x is. If x is a 3, or if x is a -2, or if x is half, it could change and it can vary. So that's why we call it a variable term. So we have things called constants, and we have things called variable terms. Okay, so that was really kind of the breakdown of this, and each one of these things is called a term. Okay, so that's where we really began with taking our notes and going back to these different activity, and then now starting with a little bit of background knowledge, now starting some notes. Okay, so here's where we started with the notes, and we said a term is a part of an expression that's separated by positive or negative signs. Okay, so now we went through and I said, okay, I have got a hint for you that is going to make your life so much easier. So here's the hint. So what we do is to figure out what our terms are when we have a big long string of stuff like this, is we use what I call boxes. And we are going to box everything, like the whole year. We are going to use this trick over and over again. So whenever I say boxes, this is what I mean. So here's how you do this. You start at the beginning. So you see my mark, and you're going to go until you hit the first plus or minus sign, really, and you go up right before it, and you go until you hit the next plus or minus, and right before you hit it, you go up, and right before you hit the next plus or minus, you go up, and then you can kind of make your boxes from there. And now you boxed it all out. So what we really have here is we have 4 terms. We have a 3x, we have a, now this is why we use boxes, because otherwise we miss this, that's a -7, we have a positive x, and we have a positive 2. Okay, so we have 3x, a -7, an x, and a positive 2. Okay, so here's the definition for terms. It's just part of an expression separated by positive or negative signs, and we said we had 4 terms after we boxed them out. Now the coefficient then, once we box those out, the coefficient is just the number part. So anywhere you have a variable, anytime you have a term, one of those boxes that has a variable in it, it's got to have a coefficient. And a coefficient is just the number part. So just the 3 and just the 1. Okay, so that would be the coefficient. If you don't see it, like before, if you box out the positive x, you don't see that 1 there, but it really means I have 1x. Even if it's not there, it's invisible. If I were to have inside a box a negative x, you really have a little invisible -1 in the front. There's a coefficient there because it has a variable, but it's just a little invisible -1. So sometimes I'll tell people to actually go ahead and draw that in. So that's a -1x. So the coefficient is -1. Now, as you go through this then, we also have like terms. So as we are doing like terms, we use our boxes again. We use our boxes again, and we say, oops, excuse me. I don't know what just happened there. Okay, so we use our boxes again, and we say, okay, like terms. These would be any of those columns like we had before. If those would go in the same column, meaning they have the same variable, everything about the variable has to match, then they would be like terms. So we went through and we did a lot of highlighting and said, okay, the 6y and the -3y, because they're both y's at the end, would be like terms because they have the exact same variable. Okay, now remember, if I were to have a 2y squared, that would not be a like term because the y is squared instead of just a regular y. The variable and the power have to match exactly for them to be like terms. Now, a constant, what we talked about before, just plain numbers. Things that are exactly the same, or that don't have a variable at all in it. It's just a plain old constant number. So the only one here would be the positive 3. That's a constant. Okay? So we went through then, and in your notes, we went through and said, okay, what are our terms here? And highlighting like terms. So this was some practice that we did in our notes. So the first thing we did is we boxed them up. I'll just quickly go through the answers here and why we did what we did. So we had an 8x and a negative 6x were like terms. Okay. We also had the x squareds that match here. So those are also like terms, but they're different. So we used a different color to highlight those to say x squareds and x squareds go together and x's and x's go together, but they're different. Okay. To highlight our coefficients, we would just underline just the 5, just the 8, just the 7, and this is why we use boxes to catch that for that x, it's a negative 6 is really that coefficient there. That's a negative 6. Okay. I don't have any constants at all. There are no plain numbers in this. You don't always have to have a constant either. Okay. Next, we did another example. So we had this in our notes as well. So we boxed them up. And we said, okay, like terms, x's. 3x and the 4x are like terms. The y really doesn't match with anything. So we said, okay, coefficients. Oh, my purple disappeared there for the x. Okay, so then we went through and said coefficients, just 3, just a positive 4, and another positive 4. Anytime you've got a variable, you have to have a coefficient with it. Okay? Come on, Mark, stay there. All right, so there's that one, the 3 and the 4, but my marks are not staying on the screen right now. So then we also had this one. So we had 5x, a 3, the 4x, and the 7. So come on, boxes. Oops, and they showed up. Okay, our like terms here would be a 5x and a 4x. And then coefficients, or constants, constants also went in the same columns that we had before. So yes, those are considered like terms. Just because they don't have a variable, they're also matching. So then coefficients only go with the ones that have the variables. So just the 5 and just the 4 would be coefficients. And then the 3 would be a constant. And the 7 would also be a constant. So we went through and double underlined those. And then I think this was the last, no, we had 2 more examples. We had this example where we boxed up those terms. We said the like terms was a 6x and the x. And then those were really the only like terms that we have. There were no y's to match and there were no other constants. So that was it for like terms. The coefficients, there are 3 variables here. So there has to be 3 coefficients. There's a 6. This is why we use boxes. There's a negative 2. And the x doesn't have one, so there's really a little invisible negative or a positive 1 in front of that x. So there's a 1, there's a negative 2, and there's a 6, are really what our coefficients are. And then we do have a negative 5 for a constant. Okay. Now, this was the last one. You didn't have this part, was not in your notes actually. So we had these 3, a 4x, a 6, and a 2x squared. We actually had no like terms here at all. The x and the x squared, those don't match. Those are 2 different things. The exponent makes it different. So then we said, okay, our coefficients, anywhere there's a variable, so there's a 4 and a 2 for the coefficients, and then the constants was the 6. The 2 there and the 4 there as well were just the coefficients, and the 6 was a constant. Okay, so then we did some flash practice as we went through, and that's really the notes for finding or the different terminology. And we went through a whole bunch of flash practice. as we went through, and we said that was a coefficient, or coefficients were just the number parts here. So if you want to look through at those really quick, let me show you what these were really quick. So we said that was a 3, oops, a 3, a -6, the x, because it's a variable, it's got an invisible 1 in front, and the 10 were the coefficient for these ones. And then we said, okay, like or unlike, those are unlike because there is no x in both of them that matches. These ones, these are like because there's an A and an A in each one, because we look just at the variable part. If we look at this one, the x squared and the x are different, so these would be unlike. If you look at this one, we have b's in both, so that would be like terms. And this one has a c squared in both, so these would be like terms as well. So we did these on whiteboards. Then we went through and we said, okay, list only the coefficients. So what we did is I had everybody rewrite them. I had everybody box everything out, get used to doing boxes a lot. And then I said, okay, just give me just the coefficients. So if you look at this one, I see, go back to this one. If I look at this one, I see a 10y. If we use boxes, a 10y, a 3, a -8, and an x. So our coefficient, I see 2 variable terms here. So I see a 10 would be the coefficient, and a 1 would be a coefficient here. It's invisible, but it's really there. Okay, so it's really a 1. The next one, I had everybody write this one down. We boxed it up. And we said, okay, I see 3 variable terms here, so I have to have 3 coefficients. So this one was a 3, this one was a -2, and this one was a 6. Okay, we looked at this example and said, okay, box them up. I see 2 variables here, so I have to have 2 coefficients. Got an 8 and a -1. Come on, show up. -1. That's really a -1. It just won't show up and stay there on the screen. Okay, and then the last one, if we boxed them all up, I see 3 variable terms, so we've got a 13, a -3, and a +4. Okay. So, simplifying like terms now, once we've got that part down and being able to figure out, okay, what are like terms when we can match them up, simplifying's not too bad. So what we do is we figure out, okay, what are our like terms? We box everything up, find our like terms, and say, okay, I've got a 4x and a 2x. Well, if I take 4x's and I add 2x's to it, meaning I want to write this as simple as I possibly can. I can't solve. I don't know what it equals yet, so I can't solve anything, but I can simplify it down and write it a lot shorter than this. So 4x's and 2x's, if I add those together, that means I'm going to have 6x's, and then I have this 6 as a box left over, so I'm just going to tack that box on the end, the +6 on the end. And that's really all it boils down to for like simplifying like terms. Now, if I were to do boxes for this, I've got a constant, and I don't have x's that'll match with this. This is really as simple as it can go. I'm not going to get 12x here because I don't have x's here. So this is really as simple as it can go. I can't go any simpler. Oh, so we went back to our different examples in our notes that we took when we had already highlighted and we'd already gone through and done these, so we just simplified these really fast. So if I looked at this and said, okay, the 3x and the 4x were like terms, 3x's plus 4 more x's was 7x's, and then those were gone. I added those together, and then I had a 4y left over, so I just kind of tacked that plus the 4y on the end, and that's as really simple as it goes. For this one, when we looked back at this example, well, I have 5x's and 4x's together give me 9x's. And then those were gone because I used those to simplify. 3 plus the positive 7 gives me a positive 10, and it looked like that. I wanted to give an example too of if it was negative. So if this was a negative 3 and a negative 7, for example, negative 3 plus negative 7 would give me a negative 10, and that would look like 9x, and we could just write minus 10. Or you could write 9x plus a negative 10, and both of those things are the same thing. They're just written a little bit differently. Yep, and both of those things are just written just a little bit differently, but they are the exact same thing. So either way would be totally acceptable. Okay. For this one, okay, we said 6x plus one more x, because that's really a 1 there. One more x gives me 7 x's. And then that's all I had for like terms. So those were gone. So now I had 2 boxes left over. Well, I'm just going to rewrite those boxes. So I'm going to rewrite the minus 2y and the minus 5. And now it's simplified. And then the last example, if I look at this one, we didn't have any like terms here. This is as simple as it can go. This is as simple as it can go. I cannot simplify at all. It's already simplified. Okay, so those are the notes on simplifying and finding like terms and simplifying. And then I'll have another one on distributing in a minute.